Okay, so this is going to be a short video showing you how to graph your percent change in mass from the osmosis lab. So here I have some fake data. This is not our data, but this is fake data, just so you can see how to graph it. And so what I have done is calculated percent change in mass. And the reason we use percent change is because if we use total mass gained or lost, we would have to start with the same mass to begin with. And obviously it's very hard to make those little dialysis bags all start at the same. So we're just going to use percent change in mass, which we calculated from our initial mass and our final mass. So on the bottom of your graph is going to be molarity. And we went up to, on our graph, 0.8 molar. So I'm going to put 0.8 molar here. 0.4 will be halfway, roughly. This would be 0.2. This would be 0.6. That's kind of an easy way to do it. And then on this side, we're going to have percent change in mass. And so I go up to as high as, I'll just put it at 40 because that's an easy round number, 40%. Halfway down would be 20%, and then I can cut those in half, which makes it nice and easy. Okay, so I'm gonna now go ahead and basically graph my data. So at 0.2, we had a 10% change. At 0.4, we had a 15% change. And these are all positive. You can have negative, but in this case, we did positive. At 0.6, we went up to 22%, which is right about there. And 0.8, we went all the way up to 38%. So roughly, that's what my data looks like. So now what I'm going to do is I'm actually going to create a best fit line, or line of best fit. We also call this a trend line. And what the trend line does is it allows you to predict the data based on the trend of the data. And you want your line to basically, in this case, we're going to go through the 0, 0, and you want it to meet as many points as possible. So in this case, I'm going to make a line that looks kind of like that. It's pretty close. When you hand draw a best fit line, it's never going to be exact, but if we did this in Google Sheets, we would get the same exact number. Now, this tells us basically we can predict any molarity and any percent change in mass. So let's say I said, okay, well, I have a 0.3. How much will that change? I can actually interpolate that data by going up to the line where it crosses, I go over, and it should gain about 15%. Okay, very close to the 0.4. I kind of screwed up that graph. It should be a little lower than that, so maybe like 13%. Okay, now when we did our mystery was purple, so I'm going to use blue. Our mystery, let's say that our mystery gained, I don't know, let's say it gained 30% mass. All right, so that's all we know about the mystery. So I go to the 30% line, which is right here, and I'm going to draw a line over to my line. And I'm going to drop a line down. And I know that based on the data that we have and the trend line that we have, the mystery molarity then would be 0.6 molar based on our data. And that's how you graph it. It's pretty simple. You will definitely see this on a test where I give you some data and you have to figure out a mystery. It'll probably be a cell that has a certain percent change in its volume or in its mass. And so you're going to graph it and then figure out what the molarity of that cell is. And so hopefully that helped, and we will be doing this together in class. Thanks, everybody.